Okay, grade 12s, let's have a look at another example. It says PB is a tangent to the circle and PA is parallel to BC. So let's have a look here. So PB is a tangent to circle ABC. Well, what do we know? We know that B1 is equal to angle C. The angle between the tangent and the chord is equal to the angle in the alternate segment. Okay, we've got PA is parallel to BC. PA is parallel to BC. So what does that tell us? We can see that A1 is equal to B2 alternate angles. So that's quite useful. Okay, now let's see. We've got to prove that triangle PAB. Okay, let's have a look at that carefully now. Triangle PAB. Let's match make the angles PAB and ABC. So we've got to match make these angles. Let's go and look at the triangles PAB. PAB is PA1B1. So let's put the little markings there, A1 and B1. And then we've got triangle ABC, which is A2, B2, and C. So it's A2, B2, and C. Now we want to match these angles and see what reasons we can use to prove them equal. We'll have a look at this. Well, we know A1 is B2. That's proved because of alternate angles, and B1 is C because of tan chord, which is great. And then obviously we can immediately conclude that P will be equal to A2 via the sum of the angles of a triangle. So let's write that down. Okay, number A here. Okay, so what do we know? We can say in triangle PAB and triangle, if it's not PAB, it's triangle ABC. Okay, what do we know? The first thing, we know that A1 is equal to B2. Now, why is A1 equal to B2 in these triangles? A1 is equal to B2. That's because of alternate angles being equal. The alternate angles being equal. The second thing is we know that B1 is equal to C. Okay, where's B1 is equal to C? That's tan chord. There we go. The tan chord theorem. And then the last ones, that's angle P is equal to A2. That will be the sum of the angles of the triangle. Well, let's look at that. P is equal to A2, the sum of the angles of a triangle. So this is your kind of weakest link here. So that comes from the sum of the angles of a triangle there. Okay, so then we can say that therefore triangle PAB is similar to triangle AB and C. The reason, 3 pairs of corresponding angles being equal. Okay, so PAB is similar to that. Now the next thing involves a whole lot of ratios. Okay, so let's do the frog face first before we do anything else. So number B, how does the frog face work? We've got triangle PAB is similar to triangle ABC. So let's apply a frog face. We've got PA over AB, AB over BC, PB to AC. Okay, let's try that. So we can say PA divided by AB is equal to AB divided by BC is equal to PB divided by AC, using the frog face there. Now, what do we want to prove? Okay, this is important. We want to prove here that if you look at this, I'm just going to just take this out, and I'm going to take and copy it right down here so we can see what we've got to do in B. So if you go here, let's paste it there, and let's see. So you've got to prove this. Okay, now, to do it, let's have a look and see what have we got. Okay, well, in this thing, there's a PA, so we've got a PA and an AB, and another AB and a BC. So built into this proof with these two guys would be this. Now, what you need to understand, and this is very important, when you talk about PA over AB, it's the same as saying PA colon AB. The colon and the divide mean the same, and that equals AB colon BC. It's exactly the same as the divide there. Okay, so just bear that in mind. Okay, and then number C, let's have a look at number C. I'm just going to take that down and copy it so we can have a look at what we're going to do there. Here we go. And let's copy that and bring it down. Here we go. This is what you want to prove. Okay, so that's what you want to prove. Now let's see, how do we go about it? Well, if we look at what we have proved, we've got PA over AB, AB over BC. So it looks like we can use this thing again. We've got PA over AB. Okay, let's tidy up that B there. It looks ugly. Alright, there we go. So we put the B in again there. Is equal to AB over BC. Now what we can do is we can simply get the LCD or simply cross multiply. Let me show you how cross multiplying works. Do you agree that 3 over 2 is the same as 6 over 4? Okay, now if you think of 3 over 2 as the same as 6 over 4, which it is, it's the same as saying, well, let's bring the 4 up to the 3. Let's cross multiply, they call it, is equal to bring the 2 up to the 6. Now, in other words, what you're actually doing there is that 2 goes up to the 6 and the 4 goes up to the 3. It's called cross multiplication. Okay, and look at that, 12 is equal to 12. So you can do exactly the same here. You can bring the BC up and the AB up as well. So what you then have is PA multiplied, the dot here means multiply, is equal to AB multiplied by AB. That's what the dot is as opposed to the colon. So therefore PA multiplied by BC is AB times AB, which is AB squared. Okay, so just be careful of that. And then number D, let's have a look at this. Let's copy him and see what we'd have to do with him. Well, that's very interesting. We've got to prove that in number D here. I'm just going to paste him here quickly and hold him there and go back to a pen. In number D, we've got to prove this. Now, let's have a look at what we've got. Our previous ratio is PA over AB. So let's have a look at that. We've got PA over AB. This is what we've proved. PA over AB is equal to AB over BC. And that in turn is equal to PB over AC. So that's what we've got, PB over AC. Now let's relate it to what we've got to prove. Well, okay, we've got to have an AP in our answer. There's AP there. Then we've got to have an AB, which can be taken there. We need a PB or a BP and an AC. So there we've got our fractions that we can use. Okay, now have a look at this. Well, if we take out PA over AB, that's the same as PB over AC. Okay, now that is the same as AP over AB is equal to PB is the same as BP over AC. Now, what I want to show you is something very interesting. Do you notice that here, in what we want to prove, we've got AP over BP and then AB over AC. But if you look at this from our frog face, the AB and the BP are in the wrong position. So what I want to do is I want to circle these things and I want to be able to swap them around to be able to give me AP over the BP. Now let me show you something that works brilliantly. If you have a look at 3 over 2 and look at 6 over 4, I could quite easily, if you think about it, have 3 over 2 as 6 over 4, but I could swap the 6 and the 2 around, change their places. Now look at this. You have 3 over 6 is 2 over 4. Do you notice that the 2 and the 6 have changed positions? And look at this. 3 over 6 is a half, and 2 over 4 is a half. They both equal a half. So you can actually do a bit of a swap there. Now watch this. All you have to now do is you swap the BP and the AB around. So you can say therefore that AP over the BP, that goes down into AB's place, is equal to AB comes up, divided by AC. And look at what you've proved. You've proved exactly what you wanted to do there. So it's a little bit of a shortcut that you can use. It's called a version of cross multiplication.